So we are going to begin our next very important topic, just expand our language a little bit further by talking about predicates and predicate logic, right? So far we talked about propositional logic, the very first step in logic, and now we are going to extend it a little further. We said that a statement is a description of something, a description of certain object or something, and a proposition is a statement which is either true or false. So at that time we discussed that these type of statements, for example, x is equal to 4, or x is bigger than y, or y plus 3, x plus y is equal to z, these statements are not propositions because we don't know the truth value. Their truth value depends on the value of the variable or the subjects or the arguments involved at the time. But now, actually, the reason we couldn't talk is because those are actually predicates. So we'll today talk about predicates, and we would be able to talk about statements like these. Okay. So a predicate is a property, binary property, which is either true or false about certain objects. These are called the subjects of the predicate. Okay. So x is greater than 3. Now this is a property of x, right? It describes x. It is a predicate of x. Y is equal to z. This y being equal to this number or variable z is the property of y, or it's a property of z, or both, or something. Okay. So now this is what we call, in this case x would be called the subject of the predicate, the subject of the statement, and this is greater than 3 is the property or the predicate of that, right, which could be true or false. In the other case, y is equal to z, y is the subject and this equality to z is a property, or you can also say that z is a subject and y equality to y is a property, or you can say that the equality is a property of both y and z. So something which is either true or false is called property, and the property that is true or false about something is going to be the subject or the argument or the object of that property. Okay, a proposition is a statement that is either true or false. A predicate is a statement, let's say, which is true or false about certain object. It could be true about some objects and not true about some objects. I'm going to give you many examples of those things. Okay, so let's just establish the terminology. So in this particular case, x is greater than 3, x is the object, is greater than 3 is the property, the predicate, right? We denote it by p of x. It's the property, the predicate of x, right? It's a property of x. So it's generally written as p of x or q of x or r of x, just like we denoted propositions by p, q, r and stuff. This will be denoted by p, q, r, right? But there will be an argument to that. They were actually called propositional function. So p is the predicate, the property, and x is the variable or the object or the subject or the argument or the variable of the predicate. Okay. Together, this predicate of p of x is actually the value of what's called a propositional function. This is a propositional function. It spits out propositions. Just like other functions, integer functions gives output integers. Real function gives its output real numbers, right? These functions gives its output propositions, and propositions we know is either true or false. Okay, so not very important because we don't know function as such by now at this moment. So, but we'll talk about it later. Okay, so a proposition generally takes one or more than one arguments, or it's a proposition, a predicate about one or more than one variables or subjects, and it stands for the property of the variable, one or more. It could be multivariable predicates, just like we have multivariable functions, right? So these are multivariable propositional functions. It yields a true or false value for certain subjects, and it becomes a proposition when we give values to the subject. Not very important, just when we see examples, everything is going to be clear, but just for technical correctness and completeness, I had to say these big words. So, but these become proposition when variables are given value. So now things is going to be clear. P of x is x greater than 5. Is it true?
We don't know.
Yeah.
Until we know the
Yeah,
value.
it is not a proposition. So asking the truth value of this is not really a valid question. Okay? But when I give value to x, then it becomes a proposition. Right? So P of 3. What is P of 3? Not the truth value. What is P of 3?
False.
Not the truth value. What is P of 3? Just pronounce, rephrase P of 3. P of 3 is the statement or the proposition that 3 is bigger than 5. Okay? Is this clear? So when I give value, it's a predicate. It's a propositional function. When I give value to the subjects, it becomes a proposition, right? And now P of 3 is a proposition which is true or false. It's false, right? 3 is not bigger than 5. P of 7. What is P of 7? 7 is greater than 5. Is that true? Is 7 greater than 5? That's a true proposition? So it is now true, right? So now we can ask the question. It's a valid question to to ask if this is a proposition or is it true or false, because now these are propositions. P of 5. What is P of 5? 5 is greater than 5. Is it true? It is not true, right? It's false. It's clear proposition. Let's do a few examples with two variables. This is a multivariable predicates. Two variables q, x, y, x bigger than y. If I ask at this moment whether it's true or false, that's not a valid question, right? Because it's not a proposition. But if I say this thing q3, 4, what is q of 3, 4 or 3 is bigger than 4. So is it true? This is false because 3 is not bigger than 4. But how about q of 5, 4? What is q of 5, 4? 5 is bigger than 4, a valid proposition which happens to be true. Yes? Q of 4, 4. What is q of 4, 4? Somebody here. 4 is bigger than 4. Is that true? It is not true, right? It is false. So we know that. Okay, let's a few more things. Some of the x, P of x is a predicate. P x is a professor at LUMSx. Okay. So if you ask about me, P of Imdad, yes, I am a professor at LUMSx, so it's a true statement, right? P of Pythagoras, what is it? What is the statement? Pythagoras is a professor at LUMSx, right? So maybe it's an anthropology professor, but P of Dr. Malik Jahan, is he a professor? Yes, he is a professor at LUMSx. Dr. Malik Jahan leads the other section. So, yes, please. Being a professor at LUMSx is the predicate. X is the subject of this propositional function.
Propositional function is only P of bracket x, right?
Yes, P of x that's a shorthand notation for this big sentence.
This whole is a
Yeah, P of x is a proposition.
propositional function.
It's a propositional function. Yes, sorry, predicate. Okay. Q of x, y, z. This stands for x teaches the course y in the university z. Okay. Now, I just want you to understand this thing that Q of x, y, z generally for whatever. Okay, so let's just see an example. Can you say the statement Q of Imdad calculus in ITU? Say the statement. In ITU, right? So I teach calculus in ITU, that's a statement, right? Is it true or false? False. Now, if I were to switch the order here, just says, write Q of calc, ITU and Imdad. What would the statement be? No, not the value. What would be the statement?
Calc teaches course in that.
Yep, it's a meaningless statement, right? So there is a thing there that in some order these variables have to be given value, and we'll talk about that in detail, right? So is this true? This is false, right? Because as far as I know, Pythagoras teaches biology in Punjab University. Q of Pythagoras bio PU. What's this? So Pythagoras teaches the biology course at Punjab University. Is this true? It's false most probably, but you know what the statement is, right? Dr. Jahan teaches discrete math at LUMSx. That's a true statement, right? He teaches the one section of discrete math at least. So depending on what do you mean by teaches and what do you mean by Jahan, this could be some other Dr. Jahan, right? It could be some other LUMSx. Yes? So Larkana University of Medical Sciences could be another LUMSx, right? So those kind of things you have to figure out what do we mean by that in the context, it should be clear. Okay, so let's talk a little bit more, one more example, and then we are going to do more things. Q of xy is the predicate x is bigger than y, right? Both x and y could be subjects, the generally are, and one being, the first one being bigger than the second one is going to be the thing, right? So Q of 10, 7, what is the statement? 10 is bigger than 7. Why can't we translate Q of 10, 7 as 7 is bigger than 10? Yeah, so we have to, this unspoken order between x and y, when we give them, sometime we'll have to give explicitly those things, okay? So just keep that in mind. That's why I chose this example. That's why I asked you earlier about if I replace Imdad with calc and calc with ITU and ITU with Imdad, it will just become a meaningless statement, right? So this statement, irrespective of whether it is true or false, 10 bigger than 7 is meant by this statement, right? Not 7 bigger than 10, okay? Irrespective of what is true, what is false. Is it clear? Yes? Yes, please. You can do whatever way you can interpret. That's another thing of retranslating, rephrasing thing. But you cannot, if you've written x bigger than y and you give the value, so there is this subtext of saying that the value of x is 10 and the value of y is 7. That's what I want to emphasize. If you want to say that x is bigger than y, well, what if you say x is greater than or equal to y? What if you want to translate is the value of x is bigger than the value of y, right? Or you can also say it in many different ways, y is smaller than x, if I subtract some non-negative number from x, only then I get y. Some positive number from x, I get y. All of these are valid English useless translation, okay? Feel free to waste your time on that, but this is what I meant to say, that you cannot make this mistake. You cannot switch the thing, okay? You can all play these linguistic games. Here is the thing, if you know now so much, answer this question. Can you pronounce the statement, Q of cat and y? 4? Is it true?
We don't know. We don't know what 4 means with respect to the cat.
4 is a number. Cat, you can see my cat, a specific proper noun cat. What is its truth value? Who said it's not a proposition? I said you give some value to x and give some value to y. Cat is the value of x. Who said what makes sense? What only thing that makes sense is the previous slides. Nothing else makes sense so far, okay? You can't just bring stuff out from it. There is something lacking. There is a gap in our language, in our grammar. Yes? You want to say something?
They're not the same data type.
Well, did I use ever the word data type?
Sir, can it depends on the context? Maybe the cat is larger than the number 4 when written on the paper.
Oh, that's a cool idea. What if I enlarge the font size of 4?
Then it's false.
Okay. So you see the problem here? Does everyone see the problem? We don't have the tools to deal with this case, right? Because we should have defined something. I can ask this thing, Q of course mountain. Course bigger than the mountain? Which course, which mountain? You can make it a specific course in a specific mountain. I don't know, I am asking you. You can just throw back the question at me. Would the answer be? I'm asking you. Okay, so this brings us to a very, very important concept of what's called the universe of discourse. Okay, we all have to agree whenever we make predicates and propositions and this logic. We agree on something called the universe of discourse. What are the collection of valid subjects? Just like when you write a computer program, you specify in the argument that it takes int x, right? Int x is one of the parameters of the argument, and then it does the square of x and return the square of x 3 times the square of x. Now, if somebody input an image to it and they tell you they did not output the square of that image times 3, then it's not your responsibility, right? Because there is a set of valid inputs, a set of valid values for the subject, for the argument, one or more arguments, and only that you are responsible for to translate, to assert their truth values, to say it's true or false, or to translate or to use in further in your language. Does it make sense? So once you have the universe of discourse clear, written explicitly or implicitly clear from the context or other things, we're going to do some examples. We may not have to really explicitly state this all the time, but each variable needs a universe of discourse. They could have actually a different universes of discourse. Different variables could have different things. Okay, so here is a question. I have a statement P of x, x is bigger than 4. Which one of these 3 is an appropriate, more suitable universe of discourse for the variable x? Set of people, set of real numbers, or set of cats? So everyone knows, right? So if it is so clear from the context, we won't explicitly say it, right? But it has to be clear. Okay? Remember, this is a language course. We have to learn language. And the clarity of your language actually leads to clarity of thoughts and clarity of solutions, and everything is going to be clear if you are clear in your thinking and you think in language. So language has to be very, very clear and precise. Okay? Okay, P of x, x is a professor at LUMSx. Which one of these 3 is an appropriate universe of discourse? Set of people, set of cats, or set of real numbers? The set of people makes more sense, right? Similarly, x bigger than y, that was the one where we were stuck. We'll need 2 universes of discourses, x and y, right? For x it will be one thing, and for y. Would it be a valid universe of discourse or a sensible universe of discourse if x takes value from the set of people and y takes value from the set of real numbers? Yes or no? Will it make sense if I say the set of x, universe of discourse for x is set of people and the universe of discourse for y is set of real numbers? So this makes sense that both of them should be set of real numbers, right? Not cats. Is this clear? The universe of discourse, just the universe of things we are talking about, right? Or is are valid to talk about. So they can have different universe of discourse. Here is a q, x, y, z, a 3 variable predicate, a 3-dimensional function. Not 3-dimensional function, but a 3 variable, 3 parameter function. Q of x, y, z. X teaches course y in the university z. Okay. What is an appropriate thing for x, universe of discourse for x? Can I put the set of cats in the universe for x? Set of courses for x, set of people make more sense, right? For y, it should be the set of courses. For z, it should be the set of universities, the list of universities in Lahore or in Pakistan or in the world, depending on what are the things you are talking about.
So essentially,
Yes, universe of discourse. It's a set. I don't want to ever use a word such in this sense because we haven't talked about set theory. It's going to come next tomorrow, so I don't want to go to the too much details of those things. Yes, you know what I mean, right? Okay, so this was all about predicate. You see, we already have a lot. There are stuff, this x greater than y, x equals to y plus 3. These were the things that we couldn't talk about up until yesterday, right? We said, oh, they are not propositions. We did talk a little bit about them, for just force them because there was no way out. But now our language is much expanded. We have the ability now to talk a lot more about many things. Okay, so let's see what can we further do with this. Yes, please.
Therefore, cat is greater than 4, we'll just say it's not a sensible universe of discourse.
Yes.
Thank you.
Sorry.
For cat is greater than 4, we'll just say it's not a sensible universe of discourse.
No, cat greater than 4 is not even a valid statement. X bigger than y, the universe of discourse for X being the set of cats in Lahore, all cats in Lahore, is not a sensible way to use in the context of that cat number 1 is bigger than cat 19. That doesn't make any sense, right? So just specifically saying cat bigger than y is a statement which is just a meaningless statement, right? Okay, shall I go further? Okay, yes, please. You want to give him the worksheet? No, he came quite early. I don't know. Okay, she doesn't want to give you. So, okay, x is greater than 3 is x. This being greater than 3 is a property of the predicate. X is the subject or the variable or the argument of this thing. We talked about all of this thing. This is just a quick review. Remember, a predicate becomes a proposition when the variable gets values, right? It could be true proposition or false proposition, but that was the most important thing. So, propositional functions become actually proposition, predicates or propositional functions. Technically, predicate is that one piece, the property of predicate, right? It's the correct technical word is propositional function, but we'll mention x bigger than 3, we'll call the whole statement as a predicate, right? So, but when predicate gets value, it becomes proposition, right? So, quantifiers make actually a predicate or a propositional function a proposition for a range of values, right? For multiple values all at once. Just like in English, we use these words, right? Remember, in English we use or, we use and we use if then, we gave them precise meanings. Here also in English we also use these type of things, right? All people are idiots, all students are great, all whatever, all kind of statement we make these. Some of these people are really intelligent and others are not very good, or many or few or all of them, at least some, at most 10 people are allowed in this room, or these kind of things. We want to have our language, we want to have this capability of expressing this type of statements, okay? And for that we use quantifiers. Generally, we'll talk about the universal quantifiers and the existential quantifier. There are some extensions of it that people use. I'm not going to go into the just technicalities. If you ever have to use, or if you read somewhere, then they would have defined it, and there will be just a 2 words definition that what do they mean by the given quantifier, right? But don't worry about it. There is some other stuff there. These are more important one and like kind of used everywhere universally. So, the universal quantification of this predicate P of x is this proposition. When I want to make a statement is the following, I use the universal quantifier. When I want to say that this predicate, this property is true for all x, okay, or I want to say this with P of x is true for all values of x. Of course, for all values of x, I mean all values within the universe of discourse, right? So, this type of statement is made with so-called universal quantification, right? All the property P is true for all possible values of x, all valid values of x, right? This program outputs this true output for all inputs. That type of statement is made with for all x. This is the shorthand notation for it. For all x p of x, right, is pronounced as for all x in the universe of discourse p of x. By p of x we mean p of x the property holds or p of x is true. Okay, so this subtext, please remember, for all x within universe of discourse, p of x is true, this subject. Okay, again we'll give you more examples. And any questions so far for all x p of x? When you know the need of this, right? We will talk the whole course is going to be about for all x and there exist x. This is very essential for our communications. Okay, we can't talk about without these kind of constructs in our toolbox, in our vocabulary. So for all x p of x is essentially, we'll talk about this a little bit later, but it's like the end of over the entire universe of discourse. So when I say for all x p of x, roughly speaking, I'm seeing this is roughly speaking, because there is the issue assuming the universe of discourse is finite, but for infinite this could make different statements. So for all x p of x means I want to say p of 1 is true if the universe of discourse is 1 to n, right, some fixed number of integers. P of 1 is true, and p of 2 is true, and p of 3 is true, and p of 4 is true, and all the way up to p of n is true. Okay, so the proposition for all x p of x, I told you this quantification makes proposition out of predicates for a range of values, but it does convert predicate into a proposition. So it's a proposition. When is it true? Is it true? Is it false? These kind of statements now we can say for all x p of x is true if and only if p of x is indeed true for every x in the universe of discourse. Okay, with examples hopefully it will be more clear, and if you have question you can ask now or later. Yes. This is your choice. Set of people. We just saw examples where the universe of discourse were people. List of universities, set of courses, set of numbers is not the only thing. Let me just make this statement. Here is the statement. P of x is the property that x plus 3 is bigger than x plus 1. The universe of discourse for x is all real numbers. Right? Now I am making the quantified statement. For all x p of x. Can you translate or rephrase this blue statement? Not complete. No, that's just pronunciation of it. Rephrase it. For all x p of x means what? Someone here, please. What is for all x p of x? Can you rephrase it? Let her say it. No? Is real numbers. Say this statement. Can you say this statement in English?
All x p of x in the universe of real numbers.
Yes, you.
For all x p of x means x plus 3 is greater than x plus 2.
Yes.
For all values of x that are within the universe discourse, p of x, the property is true.
Anyone, any other attempt? More easier, even more plain English, like kids? Yes. You never mentioned x for all real. Yeah. But that is wrong. I just told him it's wrong. You endorse his answer? Yes.
For every real
It's not wrong, but it's not right either. Yeah.
For every real number, x plus 3 is greater than x plus 1.
Well, if you really think about this statement, you translate it into Pashto, you will see there is some mistake there in Urdu. You just said everything that's written on the slide. Yes. Yes. Yeah.
X plus 3 is greater than x plus 1 for all values of x.
That's basically much better. Still you missed something on the slide.
For all x plus 3 is greater than x plus 1.
Yeah, that's what I said here. For all x plus 3, p of x and for x plus 3, that's correct, yeah.
Sir, do we have to include the word true?
That's not the thing you missed earlier, you missed x, yes.
For all x px, x plus 3 greater than x plus 1, where x is real number.
Yeah, but what is p? If you want to use x plus 3 bigger than x plus 1, then why do you bring in p? P is just a shorthand notation for x plus 3 bigger than x plus 1. So, what's it? Okay. So, yes.
For every real number x, x plus 3 is greater than x plus 1.
That's a much better, much cleaner translation. You see, every one of you know this answer, right? I'm going to give you some attempts of doing it. There is no right thing, because that's because of English is a really strange language, right? We will say you can just express the same thing in 19 different ways and none of them will be correct, right? With some context, because of the slide and other stuff, you will make some sense out of it, but otherwise it's going to be this. But that's why you will need a lot of practice with this, okay? A lot of practice with this. You have in the problem set, we are going to do a lot together, and others you will have to do on your own, but this is a very, very important step of this thing, okay? We are building, these are really the foundations of our language. But this statement says, okay, so let me just say, if you want to tell this statement to any kindergarten student, suppose they know real number, you can tell them, you take any real number, add 3 to it, and then add 1 to it. The first number is going to be bigger, right? So, for every real number x, x plus 3 is bigger than x plus 1. That was the last translation I got roughly from you. For every real number, adding 3 to it gives me more than adding 1 to it. Okay? Is the statement clear? That's how you will never have to translate it like this. Generally, we will be working the other way around, but so that you have to know this translation also, so you can do from English to math translation also correctly. Okay? Okay, is this true? So, is this true for x equals 1? Why is it true for x equals 1? It's not true? It's false? Okay, why is it false for x equals 1?
It's true.
So, why is it true for x equals 1?
4 is greater than 2.
Because 1 plus 3, which is 4, is bigger than 1 plus 1, which is 2, right? Is it true for 0.1, 0.1?
Yeah.
Why? Quickly.
Sir, because we're adding a bigger number on the left side, so it will always be bigger.
Yeah. Is it true for 0.1? Why?
Because we're adding a larger number, so it's going to be.
We are adding a larger number to what? We are not doing anything. We are just talking. Okay? We are just talking heads. We are not doing anything. We are not engineers. We are not scientists. We are mathematicians. We are talking. Okay? So, why is it true for 0.1? Yes, because 0.1 plus 3 equals 3.1, which is bigger than 0.1 plus 1, which is 1.1, right? So, 3.1 is bigger than 1.1, that's why it's true. Is it true for negative 10.17? Negative 10.17? No? Yes or no? It's not true for negative 10.7? Why? Is it this statement true for negative 10? When the value of x is equal to negative 10.7, then is p of negative 10.7 true or false? True, right? So, didn't you say no?
So no, I was confused between -7 and -9.
Okay. So, that's okay. So, if you make an arithmetic mistake, that's okay, because I make many. But there is nothing to confuse about, right? It's a statement, will either be true or false, right? It's a proposition. This statement says, like I asked about 1 and 0.1 and negative 10.7 and 17 and negative 18, I can ask. This statement says it is true for any number. You can pick any number, big, small, big, real, integer, positive, negative, pick any number. This statement will be true. right? Now, what is this statement saying? Is it actually true? Is this statement true? Is the blue statement true? Right? The blue statement seems to be true, right? You can try a few elements, and then establishing the truth of a proposition is what we are going to study more in proofs. Okay. Here is another predicate, quantified predicate. For all x, x squared is less than x. The universe of discourse is positive integer. Don't jump. Nobody asks you its truth value. What is this statement saying?
So in the last slide, in the universe of discourse was a set of real numbers.
Yes.
Which is infinite. But
Yeah.
we were assuming in the last slide, in the previous slide, that it should be finite.
No, I never assumed that. I just told you that you see this, that's exactly what I told you. That it's somewhat of this thing, but there are some, you see this like is also in quotes, so it's not, we never assumed that. Universe of discourse is just universe of discourse. I just wanted you to understand for all, because you know and, so that works for finite domains only, so that's why, don't worry about that. Okay, what is this statement saying? Some plain English easy translation. This should be easier for you to answer. Somebody there, red shirt, glasses, yes. Quickly. That's all you see on the board, on the slide? You never mentioned the universe of discourse, yes.
For every real number, if we multiply the
Where is real number coming from?
oh sorry, for every positive integer, if we multiply it with itself, it will be less than that number.
Okay, so yeah, the multiply by itself is essentially a translation of squares. That's okay. It's also when perhaps needed. Anybody else? Any other attempt? All the by the way, both are correct, except for you never mentioned positive integers. Anybody here, please? Say something. Can you pronounce this statement? Just in other words.
For all positive values of x is greater than
X is greater than squared. X is bigger than x squared. Oh, so you are coming from right to left. Okay. Yes, please, go ahead.
For all x, if x is a positive integer, then x squared is less than x.
For all x, if x is a positive integer, then x squared is less than x. Yes, please, last row. Every part, yeah, that's also a good way to do it. It was saying it right to left, yes.
For all x, the square of the positive integer is less than the integer itself.
The integer itself, okay. One more, I think that is slightly, yes, please.
For every positive integer, the product of itself is greater than that integer.
Product of itself with what? Square. The square is bigger than or smaller than, yes, somebody said so. Okay, that makes sense. But where is the x all of a sudden appear? Na? For all positive integers, x squared is bigger than x. What does it have to do with x? So for all positive integers x, x squared is less than x. That's what it says. That's correct. Okay, so you see there are tricks. All of them, most of you answered roughly correct thing with some omissions, but those are just minor mistakes, but you should do this. It's a tricky business. Okay, translation language is a really tricky thing. I would have translated like this, for example. The square of every positive integer is smaller than itself, than the integer itself. Right? Nothing wrong with that. The square of every positive integer is smaller than the integer itself. Okay? But and this it takes into account the universe of discourse, it takes into account square, it assumes people know square. So that's why I didn't say that if you multiply any positive integer with itself, you will end up with something smaller. That's also a valid translation. Okay? Tricky business. Is it true? Why is this not true? Quickly. Why is it not true? Yes. Yes, you, anyone, even if I didn't ask you, there's nothing wrong with the answer. Okay. That is false, yeah.
Sir, it is true for values between 0 to 1 but false for the rest of the positive integers.
Okay, between 0 and 1, which positive integer lie between 0 and 1?
Like 0.5 for example.
Is that a positive integer?
Not an integer.
Yeah, so this is talking about positive integer, right? It's not talking about numbers between 0 and 1. Yes?
Because our statement assumes that we're talking about all of them showing even 1 to not be the case, we'll disprove it.
Is this true or not?
It's not,
Why not?
because we can show that using
So
2
do
square
show it. You can, but do.
2 square 4 is not less than 1.
Okay, yes.
Less than 2,
This
sorry.
itself doesn't have a value until we put an x into it, but for all
No,
x
no,
it
no,
will
no, no.
have.
That's a very good thing, a good point. When we quantify it, we are actually putting values to the predicate, but a range of values, a whole set of values, a whole list of values. So now it's a valid question to ask you whether it's true or false. I've made it, I'm done. I made a proposition out of it. Predicates, quantifiers make proposition out of predicates for a range of values. So I've made it proposition. Now I'm valid, okay to ask you whether it's true or false. It happens to be false, right? But again, if you translate it, if you understand the statement, it's not going to be very difficult to say that whether it's true or false. This statement says the square of every integer is smaller than itself. The square of every integer. Whenever I make a claim, if I make a claim that all of you here are law school major, how would you prove me wrong? How would you tell me that my statement is false?
Even one of us is not a law school major, then
It's just, let me make a statement. All of you are law school idiots. What will you say? What will you say? What will be your impulse response? I am not, right? You'll just give me one, it's called counter example. Just give me one counter example and that will make me a liar, right? That will make me, my statement false, because just need one example. So here 2 squared is, if I ask somebody, that any number if you square it and you get, any positive number if you square it you get smaller than that itself, any kid will say, oh no, when I learned squaring, 2 squared is 4, 4 is not less than 2, right? 3 squared is 9, 9 is not less than 2. 0 squared is 0, which is not less than 0. Yes? Negative 2 squared is 4, which is not less than 2, negative 2. Is that a correct counterexample? Why not? 0 squared is not less than 0 is a correct counterexample. If I say, no, this statement is false, this statement is false, and I say 0 squared is not less than 0, you are lying. Will that prove anything? No, because your claim is not about zeros. Your claim is not about negative numbers, right? Your claim is about positive integer. It is false, but my counterexample of 0 doesn't disprove it. 0 is not a counterexample for this. Negative 7 is not a counterexample for this. Understand? That's okay. So this statement is actually false. Here is another one which seems to be more closer to the reality. The universe of discourse is non-positive integers. Non-positive means negative plus 0, right? Negative and 0. If I take the square, so just please say, read the statement, pronounce the statement.
for all non-positive integers, the square of the integer should be greater than the integer.
Yeah, the square of all non-positive integers is bigger than the integer itself. The square of all non-positive, if I take any non-positive integer, square it, I will end up something bigger than the integer itself. Is this clear? Yes, please. Translate it, translate the statement. Okay. What is positive integers? Sorry, say it again. What is positive integers? 3. What are negative integers? Negative 1, negative 2, negative 3. So non-positives are those which are non-positive, not positive, right? 0 is not positive, right? So not positive integers, all integers which are not positive is going to be non-positive, right? Generally people don't use non-positive, non-negative is used a lot, positive and non-negative is used a lot, but that's a correct, technically correct thing and occasionally used too. Okay, is this statement true? Why is it false? Isn't negative 4 squared 16 bigger than 4? Isn't negative 19 squared bigger than negative 19? Is it negative 1 squared bigger than 1? Negative 1, right? Why is it still not true? Yeah, because the statement says for every non-positive integer, this P is true, this property is true. For every, even one exception, one counterexample is going to disprove it. Disprove it. Proving is not true. If you want to say it's true, this is not going to work. That okay, negative 4 is, for negative 4 it is true, for negative 5 is true, for negative 6 is true. Examples do not prove anything. Okay? It just convinces you. Counterexample disprove things, right? Sorry, I didn't mean to say example does not prove anything. Examples do not prove any universally quantified statement. Counterexample disprove them, right? Examples prove other statements, other types of statements. Okay, so this is false, right? It's not true because for 0, this statement is not true. And the claim is every single element of the universe of discourse, this statement should be true. Here is another one. For all x, x squared is bigger than x, where the universe of discourse for x is positive integers, right? Again, you can translate it as that the square of all positive integers is bigger than itself, greater than equal to itself, right? If I say greater, is it true? For all x, x squared is greater than x, for universe of discourse is positive integer. Is it true? Why not? Because 1 is again one counterexample for which it is not true, right? 1 squared is not greater than x, right? But if I said greater than, then it won't be true for this universe of discourse and this quantification. Okay? This is now a true statement because you can start from 1 and go all the way up to infinity and check that this is going to be the case. Okay? Remember this, the Euler conjecture? Euler said, now we can really kosher talk about this thing because those were actually predicates, right? Quantified predicates. At that time I told you, wait one day, we will get to this, we will be able to talk about them because they were not really proposition. But this is what I had to rephrase it just to make them a proposition at that time. But here is what actually the Euler's conjecture can be written for all a, b, c, d among the positive integers. The universe of discourse for a is positive integers, that for b is positive integer, for c and for d, for all of these 4 variables, 4 universes of discourse, all of them are positive integers. So Euler said there are for all a, b, c, d. So Euler said a to the 4 plus b to the 4 plus c to the 4 equals d to the 4 does not have a solution among the integers, right? So among the positive integers. So in other words, it said that for every a, b, c, d, if you make this formula, you will never get equality. Okay? If you plug in the values of a, b, c, d, any 4 positive integers into this equation, you will never get equality. Right? Is this true? Is this statement true? This turned out to be false because one counterexample was found after 220 years by Norm Ilkes that if you plug in, there are more counterexamples, and actually the Euler conjecture is a little bit more elaborate than this. It works for all powers and 4 numbers 4th powers, 5 numbers 5th power, 6 numbers 6th powers. It's a more elaborate statement. But one case of it, because this immediately was related to a Fermat's last theorem statement that was for cubes, this is now for squares, for 4th power and higher power. Okay, so this is not true because this is one counterexample, and go home and plug in these numbers into this. The 4th power of A added to the 4th power of this B and this C will add up to the 4th power of this D. Okay, that's one counterexample is good enough to show that this statement is not true. Okay, here is more of relevant type of things. Here is a policy of LUMSx or this course or my course or whatever, CS210. That calculus is a prerequisite of this course. Most probably true, right? Calculus is a prerequisite of this course. That means every student who is in this class now registered in this course, not just in classroom, must have taken calculus, right? whatever prerequisite mean. You took it in LUMSx or you took it in MIT or you took it wherever, but must have taken calculus. You fulfill the prerequisite requirement for this course. Is this clear? Let's write this statement. There seems to be a universally quantified statement, every student, right? Let's try to write it in terms of for all x type stuff, right? So let's say C of x is the predicate. C of x means x has taken calculus, past calculus or whatever taken means, okay? X has taken the course calculus, okay? Where the universe of discourse for x is students in this class, students who are registered in CS210 now, okay? So translate this statement now. Now you have all the ingredient to be able to make a quantified expression for this statement, this blue statement. So the statement would be for all x C of x, right? For all x C, the predicate C is true, right? For all x, the property of having taken calculus is true, okay? So this is for all x C of x. Is this clear? Very easy. Let's just play a little bit more with this. Let's say I still want to say the same blue statement, every student in this class has taken calculus, but now C of x stands for the same thing, x has taken calculus or x has passed calculus course. D of x is taking discrete math, x is currently in this class, right? This is what this in this class means, x is registered in CS210, that is D of x, right? The universe of discourse is all students in LUMSx. Okay. Now give me a translation of the the blue statement in quantified. Make a quantified expression equivalent to the blue statement. Yes.
If dx, then cx.
Quantified expression. You never used quantification. Yes. If dx, then cx is not even a proposition, because what's the value of x? Just wait. I'll come back to you. Somebody here. Red shirt. Yes, quickly. Okay, yes.
For all x, cx and dx.
Good. For all x, now for all so for all x, we know universe of discourse for x, so for all means something. So for all x, C of x and D of x. Okay? Yes, please. Both तरीकों से कर सकते हैं. Let's just work with this one and then we'll come back to some other तरीका. Okay? Yes. You wanted to say something? Okay. So for all x, C of x and D of x, right? One way to understand what's being said and if your translation is actually correct or something is to retranslate, right? That's how you check. How many of you are familiar with? Okay, Google Translate, actually that's how it learns. It's called generative adversarial learning, right? They just they translate from English to Urdu, then from Urdu back to English. Now they have the thing, if it translates roughly to the same thing, then you know okay, your English to Urdu translation is roughly okay, right? If these are more alike the English version. Suppose you have more elaborate machinery for English language rephrasing, then one way to test Google Translate is to first translate it into Urdu, then translate it back into English using your translation machinery, and then use your English language testing capability to see if the original and the retranslation are actually the same. If they are the same, then your translation and retranslation was correct. Yes. Wait, we'll come to this. Let's see the way we written. Let's analyze that first. We'll come back to other ways of doing it. We're going to talk a lot about this slide for a while. Wait, yes, somebody raised hand there? No? Okay, what do you say? What are you saying?
I was saying a statement falsely.
Why? Why do you think this statement is false?
The universe of discourse is all students in LUMSx. So if a student from SAS1 has taken calculus, okay, he's not taking dx, so cx to true, but dx is false. So
Yeah. So that's what I was telling. So his idea, I'm going to just restate what he said. But what I was telling you, you look at the statement, you retranslate it into English, and then you will see that there is actually maybe some problem. If there is, in this case, there is a problem, exactly what he identified. Let's translate this into English. Don't look above, just look at this, the universe of discourse in C and D, right? Don't look at the blue statement. What does it mean? Can you pronounce it? You. Please, quickly, look at this statement, plug in. So, you know the universe of discourse, you know C and D. How would you say this statement in English? Previously, we have been doing this thing in English, right? A lot of this statement. Let's just do the same thing here. Just one sec.
For all values of x, cx and dx is true.
Yeah, but there's not values of x. Now, these are people. I mean, this we have just make it more, give it a more human touch. Yes, please. Yeah, Cap. That's a good translation.
Every student in LUMS has taken calculus and is taking.
Yeah, every student, so you don't even have to bring x. Every student in LUMS has taken calculus, C of x is true, and is taking discrete math, D of x is true. Yes? Every student in LUMS has taken calculus and taking discrete math. Now look at it. Is this maybe true or false? Forget about this. But does it sound like the blue statement? Does it sound like the blue statement? Yes, please.
Sir, can we modify our universe of discourse here?
You can. The previous case it was exactly the same statement. Our universe of discourse was the students in this class. In that case, we agreed that this blue translation is the correct one of the blue English statement. Right? We actually did that. We changed the universe of discourse, and now problem appeared. Right? Now we have a problem. Does everybody see that this red statement is not the same as in meaning in to the blue statement? Right? That's not what is meant by the blue statement. It's clear. Do you see the mistake here? Did everybody see that the blue statement and the red statements are different? They're not the same. Okay? So, this is a totally wrong translation. The correct translation would have been what we got earlier as a suggestion, though there was no quantification then, that for every student in LUMS, if that student is now sitting in discrete math, then he must be a human, then he must have taken calculus. Yes? These are exactly the, so she said, okay, let me just repeat because some of you may not have heard it. She said, the blue statement could mean two things, roughly, or this blue or that blue. That if you have taken discrete maths, if you're currently in discrete math, then you must have taken calculus, right? And the next statement she says that if you have taken calculus, only then you are allowed in discrete maths. Roughly the same that's kind of statement she made. Those are exactly the same statement. You are just stating the contrapositive of each other. Okay? What discourse means, what this statement means, that it doesn't mean that look at the converse of this statement, right? Everybody who's let me make a statement. Everyone who takes calculus also goes to discrete math next year. Is that what is meant by the blue statement? Is that new statement true, the one that I just made? Everyone takes calculus, right? Many people take calculus, law major take calculus, anthropology majors take calculus, right? But they don't come to discrete math. Because that's the converse of this statement, that's not true. This one, so if you have not taken calculus, you cannot come to this course. That makes sense, right? That's the contrapositive of this statement. So I hope I answered your question. Okay. So for all x, if you are taking discrete math, then you must have taken calculus, right? Or the contrapositive of it, if you have not taken calculus, then you will not currently be taking this course, right? D of x. If not C of x, then not D of x. Okay. So this, when somebody asks, what if we change the translation? What if we change the universe of discourse? Just the world goes upside down when you change the universe of discourse, right? This was the same statement, same policy, true statement, but if the universe of discourse was students in this class, one translation was good enough, right? In this case, when you change the universe of discourse, the statement description changes altogether, right? And then we have to be very, very careful. Okay. We talked about universal quantifier, and so let's do the next one, existential quantifier. There are other types of statements we want to make. The existential quantification of a predicate P of x is used when we want to make a statement like this. If I want to say P of x is true for some value of x in the universe of discourse, that I say there exists x P of x, right? I use the existential quantifier. When I want to say that at least one value makes, for at least one value of x in the universe of discourse, P is true, then I say use the existential quantifier. Okay, this is the notation for it. There exists an x such that P of x, right? You will pronounce it. There exists an x, again subtext, in the universe of discourse for which P of x is true. Okay, it's pronounced as there exists an x such that P of x, but we mean by that there exists an x in the universe of discourse such that P of x is true. Okay. In some sense, it is like the or over a universe, or the whole universe of discourse. When you want to say something like this, suppose your universe of discourse is the first n positive integers, you can, if you want to n, you want to say something like this, that either P of 1 is true, or P of 2 is true, or P of 3 is true, all the way up to or P of n is true, at least one of them is true. Recall that when is P or Q true? When at least one of them is true, right? P or Q or R is true when at least one of them is true. It's false when all of them are false. So we use the existential statement can be thought of as a disjunction over the entire universe of discourse, right? The proposition there exists P of x, again I am saying this is now a proposition. When you give value to a predicate through quantifier or through explicitly just one specific fixed value, it becomes a proposition. It will either be true or false. In this case, this is true, there exists x, P of x is true if and only if it's equivalent to when at least one value of x makes P true, right? When P is true for at least one value of x. Okay? So let's do this thing. Can you please say the statement? There exists x. This one? This is similar or approximately equal or something like that. Don't use it, don't use, this is not a standard thing. Yeah.
There are some values of
Okay,
x.
just one second. Here is a statement, P of x is x squared is less than or equal to x. Okay? The universe of discourse is all integers. The statement I am making is there exists an x such that P of x. Right? There exists an x in the universe of discourse such that P of x is true. Okay? Can you say this in English? There exists an x P of x with these universe of discourse for at least some or at least one integer x, x squared is less than or equal to x. Somebody else, even simpler plain English? Yes.
Square of at least one integer is less than equal to itself.
Yes, good. That's even better. So at least one integer or some integers square is less than or equal to itself, right? There is at least one. There are some integers whose square is no more than themselves, right? Is this true? No? Why not? Anybody else? Is this true? Or what would it mean if this is true? This will be true when I make the statement at least one or some, right? Not zero integers have this property. When there is even one integer who is this property, integer because the units of a discourse is integer, then this will be true. So this is true because one what? Because 1 squared is less than or equal to 1, and this statement says some integers. Is there anyone else? Any other integers for which this is true? 0 squared is less than or equal to 0, right. So, this is true for at least 2. So, and here now I come up with an example which makes it true. Previously, universal quantified statement, counter example prove them to be false. Here examples prove them to be true. Okay. A counter example, there are many counter examples. What is 5 squared? What is 5 squared? Actually, they are not technically called counter example in this case, but there are many negative examples for which this thing is not true, like those type of non examples. What is 5 squared? Is it less than 5? Less than or equal to 5? No. But that does not disprove the statement. It does not make the statement false, because the statement is not about 5. The statement says someone, at least 1 is true. 1 is good enough an example which makes it true. 5 and 15 and 7 and 19 and negative 18 and negative 20 and negative 87, right, don't prove them this thing false. Is this clear? Please understand examples, positive example, when are they used, what can we conclude from them, and counter examples for universal quantified statement, examples and non examples, right, and what can we build upon them. Okay, here is another example. P of x is the statement that x is equal to x plus 1. The claim or the statement is there exists x among real numbers such that x is equal to x plus 1. Right? There exists a real number which is equal to itself plus 1. That is the statement. Is it true? I am not going to spend too much time on translation, but that is more important rather than the specific truth value of this, right. This is a value to know when is existential quantifier and universal quantifier true and when are they false, but translation is also important, but I am not going to spend more time on translation now. Hopefully you are done, you can do it now, but can everyone see the statement is saying that there is some real number who, when I add 1 to it, and I get exactly the same real number again. Right? Is that true? It's not true. Why is it not true? Just why is it not true? Concise argument. Sorry, say it again. Yeah, okay. So just make the example word a little bit more precise. Yes.
The identity is unique and we know it's 0 in addition.
Yeah, not too much, too complicated words. Identity.
There are a lot of counterexamples.
No, there could be 9. In the previous one, how many negative examples are there? What is the size of the universe of discourse? Infinite. How many are negative? Are the non-examples more or the positive examples more? How many are non-examples? Infinite. How many are positive examples, true examples? Yeah, jo bhi kehte ho. Just 2, these 2 numbers, right? So a lot of counter example doesn't say anything, right? One counter example will disprove universal quantified statement. Existential quantified statement is not disproved by 19 billion or 19 trillion counter example. Actually, this one has infinite counter example, the previous one, right? Why is this not true? Because no real number has this property. No real number has this property, right? Suppose some real, we will prove it, this later proved by contradiction. Suppose some real number had this property. Suppose this statement was true, meaning at least one real number has this property that when I add 1 to it, I get it again. I get the same number back, right? So there is a real number x such that x is equal to x plus 1. Then if I subtract x from both sides, I get that 1 is equal to 0. And that's the contradiction, right? Our number theory breaks down. So this is a false statement, right? Okay, there exists an x such that square root of x is less than 4. Among the universe of discourse, these six numbers. The purpose of this example is just to make you understand what is actually meant by there exists x. What does this say? Can somebody translate this statement quickly?
there exists an x for which like multiples of 2 between 10 and 20 are there. The square root of multiples of 2 between 10 and 20 is there.
Yes.
At least one of these 6 numbers has a square root of that.
Yes, that's an easier one. At least one of these 10, 12, 14, 16, 18, 20, the square root of at least one of these 6 numbers is less than 4, right? Or now there was a person who wanted to do more fancy translations earlier. This is now the case. There is at least one number which is smaller than 16 in this among these 6 numbers, right? At least one number is smaller than 16, or whatever way you translate. Is this true?
Yes.
Is this statement true? Yes or no? Why is it true? Good. Square root of 10 is less than 4. That's good enough a reason. One example will make it true, right? Will prove this to be true. Okay, so true for there are 3 examples. Even though there are 3 counter examples, negative non-examples, but still this is, yes?
Wouldn't there negative roots also count as positive?
But they are still smaller than 4, right? So the negative root of 10 is smaller than 4.
I'm talking about the other one, 16, 18, 20.
Well, I never said this is false for them. You see, I was technically correct. I never said this is false for 16. I'm saying the statement is true because 10 is a counterexample. Can you not hear me, right? Okay, so can I go further? Right, everyone know this thing, knows. Here is a statement. Some student in this course has chemistry, has taken chemistry, right? Fortunately, not, but let's say this is the true thing, right? This is the true state of the affairs, that somebody has taken chemistry, or you can replace it with anthropology or software engineering or any other of that stuff that people do. Translate it into C of x now is x has taken chemistry, right? Just like previously was calculus. And the universe of discourse is students in this class. Give me translation of the blue statement in quantified, is a quantified predicate using C of x. Did everybody get the question? Yes. There exists an x such that C of x. Yes. Anyone else? What did you want to say? There exists x such that C of x, right? There exists x C of x. Yes.
For some x, C of x.
Yeah, there exists x C of x. Now I want you to use the existential quantifier. Okay. You translate it back to English, you will get there exists x. There exists someone in this universe of discourse who, for which C of x is true, meaning who has taken chemistry, right? Correct translation. Let's change the universe of discourse like we did with the calculus thing. If the universe of discourse is all students in LUMS, D of x is the predicate that x has taken, x is in this class, and C of x is that x has taken chemistry. Go. Existentially quantified statement, translation of the blue statement. You want to say something? You, yes. Yeah, go ahead. Don't look, no, just say it. Just, yes, you. Answer my question.
So I think this would be true because
Sorry?
the statement will still be true because it's
Which statement? Make a statement. I want you to translate this blue statement into a quantified.
for all students in LUMS, there exists an X which has taken chemistry and is taking discrete mathematics.
Why is for all student in LUMS coming from?
Universal discourse.
No, but there exists some student among the students in LUMS. There exists X such that. What else? So that's what's wrong. Okay, don't confuse yourself. For all students in LUMS is nothing. No, not important. Important is there exists X. For all has a different meaning, right? There exists X, and when I say there exists X, the universe of discourse means I mean that there exists X among LUMS students. Then what?
There exists an x that is taking chemistry and is
Yes, use C of x and D of x.
C of x plus d of x.
C of x implies D of x?
And d of x.
C of x and D of x. Yes.
There exists an x such that d of x and c of x.
There exists C of x or D.
There exists C of x. There exists x and
C of x or D.
C of x or D of x. Yes.
There exists an x if d of x then c of x.
If D of x, then C of x. Yes. You are here and now settled. Can you answer my question? Yeah. C of x. Okay. So I got quite a few translations. Some of them were C of x and D of x. There exists x, C of x, D of x, C of x or D of x. There exists x, C of x implies D of x, and you said C of x. Right. Let's just begin with that. Let's translate there exists x C of x. Translate it back to English. Translate it back to English. There exists x C of x. There exists a student where? A student where? In the universe of discourse, yes. Then who has taken chemistry? Is that what the blue statement says? So what's wrong with the blue statement and this your translation? No, universe of discourse I gave you. This is the universe of discourse, students in LUMS. What is wrong with your statement? There exists x C of x. Which part of the blue statement it doesn't incorporate? In this class, right? So it doesn't incorporate D of x. It doesn't take into account this fact that I want to say someone in this course has taken chemistry. What you said, somebody in LUMS has taken chemistry, which is also a true statement, but that's not what the blue statement says, right? The blue statement says, okay, so let's go to which order did we do? This. What did you say? Look the or one. There exists x C of x or D of x. Can you translate it back to English?
There exists some student in LUMS who has taken chemistry
or is taking discrete math. Have you taken chemistry? Anybody who has not taken chemistry? Good, clean person. Yes. Suppose nobody has taken. Suppose C of x is, and instead of chemistry it was anthropology. What will be your statement? There exists someone in LUMS who is taken anthropology or who is taking discrete math, right? A true statement. But is that what this blue statement is saying? Not, right? Similarly, it's not true. What else was there? C of x and D of x, let's say. Or C of x implies D of x or D of x implies x. So she translated as there exists an x such that C of x implies D of x. D of x implies C. There exists an x such that D of x implies C. If the person is taking discrete math, then the person must have taken, or this person has, the x has taken calculus, chemistry. That's not what this statement says. Someone is taking. What you said, there exists an x such that if C of x, sorry?
There exists an x that if d of x,
if the person is taking discrete math, then it's taking calculus. Okay. Pick some person in business school. Think of a person in business school who is not taking chemistry, right, or let's say anthropology, and who is not taking discrete math. But you made a statement, somebody in LUMS, if is taking discrete math, then he or she has taken anthropology, right? Now, about that idiot in business school, D of x is not true, false, and C of x is false, right? So, false, the statement is true, right? This is not what the blue statement is saying. The blue statement is saying, talking about people here. So, okay? So, the correct translation is C of x. There exists someone in LUMS who is now taking discrete math and who has taken chemistry. right? That's what the blue statement is saying. Okay? Okay, so the point is that with and you have to be careful with this, if this is universal quantifier, and generally it doesn't work and changes the meaning a lot. When we do subsetting subsets, you will see more of this stuff. And okay, so this is a summary of this whole thing. I want to go to the negation that will make, actually importantly, make these things more clear, hopefully, then I don't know, I will be able to get the third, fourth point, but we'll see. Okay, just like we said, okay, when we talked about quantifier, propositions, what's the first thing we did when we did compound proposition? What's the first thing we did? Negation of proposition, right? Make new propositions out of old ones. So negate them. What's the opposite of it, right? That's how you learn stuff. You learn the opposite of it. Now, predicates, with quantification, they become propositions. Now, let's see if I negate these propositions, what happens there, right? It's nothing fancy, exactly the same negation. But now these are specially constructed propositions, okay? So, a quantified predicate is a proposition, hence its negation is also a proposition, right? And the negation is exactly that proposition which is true if and only if the original proposition is false, and it is false when the original proposition is true. Okay, that's exactly the same thing. Now, every student in this class has taken calculus. This, in other words, says calculus is a prerequisite of this class, right? If you know the meaning of prerequisite. Okay, so this was the translation. Every student in this class has taken calculus. What will be the negation of the blue statement in English? Can you now, somebody who has not spoken before, just a minute, I want to wake them up. Can somebody please pay attention to me? What will be the negation of this blue statement in English? No student in this class has taken calculus. Yes. Not every student in this class has taken calculus. Yes, you, green shirt. No, the one behind you. Yes, quickly. No student in this class has taken. Can you translate this blue statement in Urdu? Just help me with Urdu. I really don't know good Urdu. No, in the blue statement, not the negation of it. Every student in this class has taken calculus. Okay, so now in Urdu, negate it. No, what? No, this statement. Can you say the negation of this in English? Yes. There exists is too mathematical. More English, plain English. Yes, you. What do you mean, sorry? Why are we using phone that you don't get my question now? Yes?
Not every student in this class has taken.
Not every student. Okay, those of you who answered no students in this class has taken calculus, has taken calculus. Do you see what's wrong with that thing? This one says 100% of students have taken calculus. If I want to say this statement is false, I'll say it is not the case that 100%, all 200 of these students have taken calculus, right? If I make this claim that all of you have taken calculus and you want to say that I'm wrong, what will you say? No, let me just make a statement. All of you have taken biology. No, that's not what you will say.
I just say I haven't.
Yeah, you will just say I haven't. You will just say I haven't. So that's a negative. Someone hasn't, right? So every student in this class has taken calculus. Again, say it explicitly in English, in math. It is not the case. This is not. Guys, please settle down. I want to say every student in this class has taken calculus. I want to say this statement is false. It is not true that every student in this class has taken calculus, right? That's what I want to say. So it is not the case. Which is, it is not the case that every student, so every minus anything, the negative of every is someone, right? Someone has not taken calculus. There is someone in this class who has not taken calculus. Now, there is an existentially quantified statement. The red statement now is more of an existentially quantified statement. So, I will make this thing, there exists someone in this class who has not taken calculus. There exists x such that not c of x. Okay? So, this is the translation of it. Generally speaking, when you want to negate a universally quantified predicate, you would do this thing. The quantifier flips, existential become universal, universal become existential, and the negation goes to the predicate itself. Okay? This is exactly what the DeMorgan's law told us, right? And this is what is good. Let's just do the other way of translation of this blue statement. When the universe of discourse was all students in LUMS, right? There exists every student in X. If he is sitting in this, if the student is sitting in this course, then they have taken calculus, right? The negation will be, again, there is some student in this class who has not taken calculus, right? Then this is the actually I want to negate this for all x, negative of negation, not for all x, d of x implies c of x. The previous rule said flip the quantifier, negation goes inside, there exists an x which is someone, for someone this statement is not true. For someone this is, it is not the case that this statement is true for everyone. So, then after this becomes just our old logical equivalence. You apply the implication laws, then you apply the DeMorgan's law, you will get something, right? The last two follows from implication and DeMorgan's law. This is not very important. This is good enough for us. Okay, this is a good enough translation. Okay, when I want to say, please settle down a little bit. When I want to say some student in this class has taken chemistry, and you are saying no, this is not the case. Right? So, let me just say some student in this class has taken anthropology 101. What is wrong with this statement? And assuming nobody has taken anthropology 101, what will you say? No one has taken anthropology 101, right? That's the negative of this. Yes? No one has taken this one. And unless this is not the case, then my statement is true and the claim, the negative of this will be false, right? So, you will have to say no one has taken whatever I said, chemistry. Okay? There exists x such that c of x, the negative would be, it is not the case that someone, that at least one has taken calculus. It is not the case that at least one has taken chemistry, basically says no one has taken chemistry, or everyone has not taken chemistry, right? So, every student in this class has not taken chemistry. Again, generally speaking, when you negate a quantified statement, in existentially quantified statement, the quantifier flips, existential become universal, and the negation goes to the predicate, right? This is the other translation, will be exactly the same, except for we will use DeMorgan's law. Okay, so this is, remember DeMorgan's law? The negation of P or Q is equal to the negation of P, not P and not Q. The negation of P and Q is not P or not Q. What happens if you really just find the pattern here? The operator changes from or to and the negation goes to individual propositions, right? That's exactly what's happening, and that's why I told you this universal quantifier is like the and over the entire universe of discourse. So, its negation would be or of the negation of individual propositions, right? And that's what these two things are, nothing fancy here. This is a simple summary of how do you find the truth value of quantifier and their negation.